Welcome everybody to ficonTEC's 5th episode in our mini webinar series for 2021. Today we will be looking at high volume manufacturing for photonics. And roll camera please. As I already said, welcome everybody to our 5th webinar in this mini-series for 2021. Oh, I have the wrong number on that slide. Mea culpa. I have the wrong date on the slide as well. Today is May the 5th. Today we will be looking at high volume manufacturing for photonics. I am joined for this webinar today. I have assistance and help from two important people in this respect. Firstly, from Frank Baumann, CEO of Duramentum. Hello, Frank. How are you doing?
Hello. Nice to meet you. I'm good. I'm fine.
Good. And additionally, from our head of sales, service, and marketing, as of the start of this year, from Augusto Mandelli. Augusto, thank you for joining.
Thank you, Greg, for the introduction. Good afternoon, good morning, good evening, depending on which part you're connected from. Nice to meet you, even though just virtually at this moment.
What are we going to learn about today? Today we're going to be examining the topic of high volume manufacturing and, in part, how it applies to photonics. As we already know, most of us very likely, photonics was already a key enabler among several other key enabling technologies for manufacturing processes, for addressing the great societal issues as defined by the European Commission. And it's a key enabler already for some manufacturing processes at high volume. Think in terms of laser materials processing in the automotive sector and in others, for example. But there are only a few particular sectors where manufacturing of the photonics components themselves already takes place at high volume. Think of camera modules in smartphones and optical connects for telecom, datacom, and 5G are just two examples we can name, and something we are seeing very recently at ficonTEC is that a similar transition is taking place in LiDAR manufacturing as well. In principle, this topic is neither new nor difficult to comprehend, but we will nonetheless touch on a number of key aspects, including the physical manufacturing considerations that one needs to make, so line dimensioning, design for manufacturing, getting the capacity of the line right, etc. We'll be looking at the key business considerations. In other words, what is the primary currency or the raison d'etre for implementing a production line system? And at what points all of these tangent or intersect with the production and process development workflow? Pretty much in all of this, we can assume that photonics is not really a special case. If it is, it's only in terms of the specific processes that photonics requires. Otherwise, most of the considerations we'll be looking at today are to a large extent applicable to mainstream high volume manufacturing as well. I've already told you who's going to help me bring you this topic today, Frank and Augusto. I'm hoping for a lively discussion. What we will do at this point before we launch into other elements of the webinar that we usually make at the start, the giveaway, for example, is I'm going to give Frank a chance to tell us, first of all, what is Duramentum, and maybe in a couple of minutes with 2 or 3 slides, put a framework around the relationship that we enjoy, ficonTEC, with Duramentum, and for what reasons. Frank, would you like to lead us in?
Yes. Gregory, thanks a lot. My name is Frank Baumann, and I'm the founder and owner of the company Duramentum, together with Ron Orlando. Together with Gregory and Augusto, I'm very pleased to give you an exciting insight in the topic high volume manufacturing line. The term Duramentum comes from the Latin and means sustainability. For us, this is always associated with our projects. Duramentum, also known as Blue Chestnut, is a company specialized in engineering services and consulting. We help you to look holistically and set the right priorities in the projects. The cooperation with ficonTEC is characterized by a lot of trust. We work together in many working places to develop excellent solutions for our customers. Our team make it possible to bring many perspectives to the table of the projects. This can be organizational things, technical, but especially process-related things. We are across all in a couple of industries. The founder of physicist and with a lot of industrial experience. We see us as a company of problem solvers for and with our customers. And we are, I think we can help you with the right methodologies, clear structures, and give the excellent support in the project and set the right key points to the table of the project.
Frank, if I have a quick question for you. So if we look at the application spaces you name here on this slide, is this an indication of, for what we're going to hear from Duramentum today, an indication of for all the sectors that these ideas can be applied to?
Yes, I think all sectors have something together, and this is in the most of our projects. We speak from industrial production. Okay. Industrial production means in product with high volume and in clear idea of a price, of quality, and of the customer of this project, of this product. And that's the main thing what is together in all of our customer in different industries and also in different places all over the world.
Okay, good. I'm sorry, I didn't want to interrupt you too long.
That's fine. Kevin, next slide, please. Let me give a little bit an idea how can we support such a project together with ficonTEC. Of course, ficonTEC deliver you an excellent technical solution, but we can support a couple of phases or a couple of different small things. Let me make some examples. Good processes are best defined already in the early phase of a project. You can see this on the left of the slide, and you see also some very small examples like capacity planning and exactly a definition of the quality of a product and which kind of KPIs are really important to fabricate such a product with a high volume and in a good price. Of course, we can support you all over the process. Process means from the first idea to the ramp up process in the after bringing the equipment from ficonTEC to the customer.
So this is effectively the holistic approach, or the holistic overview you mentioned earlier, right? You need to have a look at the whole process, and ideally you're involved with this process from as an early stage as possible.
Yes. One point is to have a holistic overview, but on the other hand, our services can understood as a kind of construction kit, I would say. do not hesitate to involve us also in a late project phase of an industrialization project. This can be in case as the phase SAT or a ramp up curve of the production line.
Okay.
My key message is make a professional cooperation with the right persons in the project and bring all questions on the table, even if it's difficult or it's not, it seems to be not solvable. That's for me the main thing in good cooperation together.
Okay, so there are various stages along this slide, which I guess can be considered access points along the process and product development workflow. I have a question for you. Is, given your experience in the different sectors you've worked within, are there any points in particular that are important or in the context of a collaboration, or maybe not is the case?
One thing is what I said: bring the right persons together.
Okay.
And with the right persons at the place, trust will be lead to success in such a project. Of course, during the project, there are a couple of key points of the project. One of the key points is for me always the FAT phase. From the customer perspective, they would like to have immediately the equipment at the side of the customer, but from the perspective of us and also from ficonTEC, it's very important to bring the equipment with the right processes on the equipment to your site, and because it's for me one key factor in all the projects what I've seen over the about 20 years industrial.
Okay. And I think it's an important point at this point is, and this is something I think we will see later as well, is that something that you will present later, in fact, Frank, I think, is that the SAT does not necessarily define the end stage of the production line, right? It is actually the initial stage after delivery, but there are ramp up and higher throughput stages that maybe need to be attained over a period of time that will then change the setup.
I really like this picture. I see this as a circle because, as you just said, at the end of every process, you really might get back into a next stage that we see is again cycling back. That's the first point. So it's a continuum. The other point, as you already said, and also Frank said, every step itself makes sense. So customers that are maybe a little advanced into their project might still benefit of this kind of activities because they might also speed up not only that specific phase but also the subsequent phases. Plus, they might represent provide good hints and good feedback also on how to improve the next cycle, the previous steps. So in general, this shouldn't be seen as the whole meal, but you can see as a subsequent steps, and each step makes sense itself.
Okay, thank you. I'm going to interrupt the flow here. News, we are hiring. I mentioned this last time, 3 weeks ago. If you, well, I don't want to poach you out of companies we may be friendly with, but if you know people who may be interested in a career with ficonTEC, we have a number of positions open. We are growing. We have been looking for new people throughout 2020 and of course onwards in 2021 moving forward. If you know somebody who might be interested or are interested yourselves, then go to our careers page and take a look at the offers, the positions that are available. Another point is that in 2 weeks' time, we'll be having a further webinar on automated assembly for quantum technology. And I hope to have, it's very likely that we will have a CEO of a startup quantum source company joining us for that webinar, hopefully somebody else as well. Kevin, back to the webinar. What we will cover, a very brief history and overview of what led to the current idea of mass production that we have today and how we understand it. and we will be briefly looking at what is the need in photonics. Why do we need to implement this transition in the manufacturing processes? So a transition away from manual steps to highly automated production. We'll be looking at the systems available for inline manufacturing provided by ficonTEC. What are the key features of those? Frank will then return to the microphone to provide us with information about how to design the line and how to optimize, for example, for uptime and for efficiency. Part and parcel of that is optimizing for unscheduled, so minimizing unscheduled downtime, of course. You want the system to work as efficiently and as much as possible. We will then move on to presentation by, or contribution by Augusto, where he will be telling us how to implement the business approach, and will provide a TCO, a total cost of ownership example for us. And then we will have a quick roundup before we finally round up the webinar itself as a whole. Kevin, next slide, please. So let me start a brief excursion into high volume manufacturing. Most of us think of Henry Ford when we think of production lines in terms of how we understand them in the modern day. The roots actually go back a lot further, even thousands of years into the past, when you look at the requirements of certain Chinese armies for the bronze parts in the trigger mechanisms of crossbows, for example, and in the production of, I think it was military weapons in the 19th century for the US military or for the US Navy, where they wanted to have, I think it was 10,000 rifles within a period of 2 years, and they only managed to manufacture 500 until they realized that they need to take entirely different approach to this problem. Around about the 19th century, the middle of the 19th century, we have contributions from machine engines and later on from electric engines as well. And then, of course, resulting from that directly, the application and the arrival of machine tools and their ability to create identical parts. And this is an important aspect of the production line idea, is that you have identical parts that can be all handled identically within the line. It makes things much more efficient. And then, of course, round about the start of the 20th century, so in the 10s and the 20s, we had Henry Ford implementing, first of all, for components, and later on for vehicles, mass production lines in his factories. There are several degrees of high volume manufacturing that we will not be spending any great deal of time on here. Obviously, a baker has always been a batch manufacturer, and that is likely very much, certainly the corner baker is likely to remain in that mode for the rest of time, maybe. There are inline production environments where components move along to a different station, are handled, are assembled, are treated, are tested. These stations exist along a production line, so there is a transition phase from one station to the next. And there are continuous inline mass production systems where the whole line moves, maybe at different speeds, at different stages, but effectively the whole line moves along past different stations. Think in terms of bottle manufacture and automotive, for example. Kevin, next slide, please. What are the essential elements? I've already mentioned the aspect that we need to be working with individual parts. This makes things a lot more streamlined in terms of being able to treat all parts equally in terms of bonding, handling, testing, etc. That is an absolute vital component. We'll be hearing later on in the webinar from Augusto how you will want to optimize for cost, quality, and time. So we can consider these to be vectors of the implementation or the currency of the implementation. I won't spend any time on that here. We will listen to Augusto later in the webinar. Another important point is that high volume manufacturing breaks with the concept of how long does it take to glue a lens. We're not interested in that anymore. Instead, what we do is we take the whole assembly and testing process, you break it down into logical steps that make sense in terms of meeting the desired throughput. You also want to have minimum handling or unnecessary handling along that line, because that consumes time and resources. So these steps are defined by process proficiency. So what does it cost? How quickly can you do it? Is the machine available? Is the process available? And you assign each step or maybe a small number of steps to a single station. So you need to have stations that are flexible in being able to handle different types of process, or maybe a number of different processes along that production line at each of your stations. And when thinking in terms of your throughputs, you can more or less very roughly consider the slowest handling step. So where something is being done to a particular component, how long that takes more or less defines your takt rate, which is equivalent to your throughput. And if you consider all of these aspects together, it is these optimizations and considerations that enable efficiency and yield and let you push down the cost per part in that production line. Kevin, next slide, please. So what is changing in photonics so that we need to think in terms of applying this idea? Very simply, if you have a look at if you have a look at the market reports that describe optical interconnects for telecom and datacom applications, for long-haul transceivers, for applications in automotive LiDAR or any other LiDAR fields come to that, biophotonics, medical technology, all of these sectors across all regions are predicted to grow at something between 25, sometimes even 40% over the next 5 to 10 years. And if you think about those and the number of components that those different sectors require for the end application, then you quickly realize that the assembly per hand is no longer a viable concept in this type of scenario, if that growth is then actually going to take place. Kevin, next slide, please. So we already know that that photonics itself is a key enabler. We've heard about that. The applications for photonics as an enabler, as for example, in laser materials processing in automotive, but also in micro-optics or semiconductor chip manufacture. The CMOS process, lithography is an optical process. But we only now, some sectors are ahead of that game, ahead of that status compared to others. Telecom, for example, datacom is ahead of that curve. LiDAR is on the curve. There are other sectors that are behind the curve, but there are increasing demands that photonic enable components themselves progress to a high volume production concept. Next slide, please, Kevin. We have to think about what are the elements we need. So we need to have a technical basis. We need to have the tools. We need to have the production systems moving forward that form the basis of any line. ficonTEC is already well positioned to provide those sort of components into this concept, alone through our background, through the expertise, and through the number of systems we have installed around the globe. We have a modular machine design, which we will hear a little bit about more in a little while, how those machines can be flexibly employed and even reconfigured and repurposed. Those machines need to be orchestrated together in a production line environment. They need to work in harmony. So the software, the process control is practically the most important tool within that lineup. And we need to be in a position to apply Industry 4.0 and machine learning based process optimization steps so that we're in a position to take our line immediately after the SAT test, for example, and move on to a higher level of efficiency and the next stages of throughput. Kevin, next slide, please. Where is high volume manufacturing in the product and process development flow? It's in this curve. Some of you will have seen this before. It's on the right within this slide. But as we already heard from Frank, and we will hear again later on within the webinar, it is actually important to begin with the considerations and the implementation of the concept actually at a very early stage within the product development, even at the prototype stage. As much as possible, you need to be thinking in terms of manufacturing for, design for manufacturing, but additionally also design for test. And there's some other aspects that we will think about a little later on. Kevin, next slide, please. So as I promised, we're going to hear about the systems that ficonTEC has available. So about 2.5 years ago, we introduced our new next generation inline systems, production systems for photonics assembly and test. Very quickly, these are feed system capable, so they can either be use cassette feeds or other types of feed mechanism to take components into and out of the system. Alternatively, as illustrated here, we can concatenate systems with a conveyor belt running through the entire line. We can chain systems together to enable an entire production line. Each of these systems that we're looking at are modular, flexible, and versatile, which effectively means they can be reconfigured and optimized. We need to place different processes or different numbers of processes within these systems, and we need to be able to reconfigure and to adapt these systems to take up process optimizations that we have decided, that we have determined are necessary or that are important, that need to be able to be replaced maybe within the system line. And as I already mentioned, for LiDAR, we need to be in a position where our customer can move from a batch manufacturing environment or concept through to a much higher volume inline approach to the manufacturing of the devices they want to deliver to their customers in different sectors. The last thing, or an equally important point that you can do with these systems, is they can be easily repurposed for an entirely different application. And we see some of this happening with some of these systems already. And as I have already mentioned in the previous slide, practically our most important components or most important products within that concept is the software, our process control master, which is used to orchestrate the whole production line. Kevin, next slide, please. Where have we had successes already? I've mentioned these, I won't dwell. Telecom, datacom, so in optical interconnects for long-haul communications and data center applications. We are helping companies, our customers in the LiDAR development area, transition from a batch concept to high volume manufacturing concepts. And the illustration we had of 9, 10, 11, 14 systems daisy chained together was an automotive application. And there is a second line for that exact same purpose, should be going out in the very near future to that same customer. We also take part in the development of high volume manufacturing concepts at a project level. So for example, within the EU, we are involved together with other important partners, Fraunhofer IZM, for example, and NVIDIA within the MassStart project. You can follow the link massstart.eu to find out more about that project. And we had a webinar now about 6 weeks ago, if you want to find out more about what was discussed within that webinar. Kevin, next slide, please. So I've made a very quick presentation of the technology basis that is available from ficonTEC, the physical components, the production systems, and the concepts in terms of software control that are important in putting a system together. What we want to be able to do at this point in the webinar is then maybe hand over the baton to Frank so that he can then present us with some details about, okay, so then how do we go, if we have all of the elements, how do we go about successfully designing a high volume production line? Frank, please.
Before clarifying all technical details, it is important to take a clear economic view to the project. We invite you to discuss with us, means ficonTEC and maybe Duramentum, discuss the design and flexibility of high volume production lines. Let's discuss maybe different scenarios and possibilities for the starting phase and also for the expansion stages. Our consideration includes the knowledge about possibilities of the equipment. During the project discussion, we present you different operation conditions for equipment, like machine shift systems, economical OEE figures, and also personnel requirements in and around the processes. In summary, I would say let's discuss the key factors on a successful project. Let's go a little bit more to the process of manufacturing of your products. The question is often, how can we influence the success of the project? One point is we design together with you and perfect process. Like the points what Gregory said 5 minutes ago, design means design for manufacturing, design for assembly, design for test, and also design for Six Sigma for the special processes on the equipment. On the next page, I will give you a little bit in technical view. But in technical view is on the other hand always in economic view, because at the one side we can solve with a lot of technical things, very high quality and so on. But on the other side, it is always in good possibility to think in an early phase what is an easy possibility to design processes.
Frank, if I can make some comments, can we go back a slide? One of those aspects of the course ties in very well with the performance services that we offer with some of our systems for an inline manufacturing environment. And those performance services offer the ability to include machine learning based algorithms as a software layer within Process Control Master for process optimization purposes. But it also provides a high level of visibility to the data. So you are in a position to see whether there is any anomalous behavior, for example, of any components within the production line or any of the motors or any of the handling aspects of the production line. And I guess that's one of the points you wanted to make. And we covered this as well in a previous webinar that was some time ago. I think it was the end of last year. Should be in December, I think, is the webinar that covered that. So that will be artificial intelligence and machine learning based process optimization, I think is the title. And then, of course, there are these other aspects that you highlighted as being very important in that respect. If we come on to the next slide, back to the slide after that, thank you again, Kevin. Then we're sort of making a transition here to the financial aspects, right? I guess this is a nice segue into what Augusto is going to present to us. After you have achieved the physical how with the technical layer, with the hardware that's available, part of the total consideration you need to make is, so what is the business model? How do we implement a financial model here that helps best describe how we want to, or define even how we want to move forward?
I think the key is the combination of business view and technical aspects, and bring the right persons together to discuss this in the front at the first project phases.
Right. So back to your comment about getting in on the act, being involved in the process from as early a stage as possible, and being involved with the design for manufacture. Okay. As I already said, Frank, I'm sorry, I didn't want to interrupt. Is there anything you want to add?
I think we business and technically things. It's a good starting point to give the discussion to Augusto.
Okay. Thank you. Good. Frank, thank you for your contribution. But please stay online. We hope you can join the discussion. And again, something I haven't mentioned to the audience, if there are any questions that people have they want to pose to our panel, to ourselves, please do that through the chat. We would be very happy to address any questions that come up. So as I said before, this is a nice segue, starting to look at the financial aspects. Augusto, do you want to take up the baton at this point?
Yeah, absolutely. Thank you, Greg. I hope that you can hear me nicely.
Yes.
I mean, as I like to say, the process has been showed so far gravitates around 3 points, the what, the how, and the why. or you can reverse it if you want from a process standpoint. So the what is the technical part, is the technical feasibility that has been shown so far. The how, Frank was underlining nicely, the process part that is keeping the what and the why together. But as we all know, we have to start with the end in mind. So the why we're doing something, understanding whether there is the financial and the business feasibility is a key factor. That's the reason why in this specific section, I want to highlight this kind of element that I don't want to say that is underestimated, but sometimes is not fully considered. And also to present that there are disciplines, nothing completely new, like talking about tools like TCO, total cost of ownership, that really helps to analyze this specific aspect moving forward. But let's start with the first point. As you introduced nicely before, Greg, and also Frank was mentioning this, every business analysis should start with understanding in which specific landscape the organization is moving forward. And usually there are three main vectors that can be identified. It's either time or any variation of time concept. It could be time to market, it could be time to money, it could be even tax rate, so throughput. So time can come with different exceptions, or could be cost. And usually everyone thinks that cost is the only currency of this analysis. Actually, it's not. Or could be quality. And obviously, depending on which part you are, the strategy can be pretty much different. If you want a high volume to just have a faster time to market, probably you might want to sacrifice something in terms of quality. Or if you want to improve quality, probably you are ready to sacrifice something in terms of time. So it's clear that depending on which vector you want to optimize, you might come up with different strategies. So that's the first advice. And obviously, those are also the three main points, the three main pain points, I would say, that affect every niche industry. Irrespective of the industry, it could be silicon photonics, it could be automotive, it could be whatever, aerospace and defense. You have this kind of three vectors that are always identified as the main vectors across which every organization should think in terms of optimization.
Augusto.
Yeah, please.
I very much like this landscape concept, but considering the time frame within which a project like this can be put together, I can imagine that landscape could change.
That's a very good point. Actually, yes, and that's exactly why you cannot take this kind of analysis as done. Once you have done it, it's going to be valid for the life of the organization, the life of the project. Actually, I cannot mention specific cases, but I know I've been working on business impact analysis in my previous business life, let's put this way. And I saw organization having this kind of landscape being completely different depending on internal or external factors. Maybe in one situation they were optimizing for speed and for cost, let's say, and then 6 months later, because of external conditions like an acquisition or the company was spun off, they were optimizing for speed. So you're right. And in this sense, having an agile process and a view on the process, as Frank was identifying before, as well as a platform that can be is modular and can be adjusted depending on the needs, is obviously a key point. But again, everything starts with understanding which landscape you are. So very good question. Thank you. So if you move to the next slide, one point that has to be highlighted, and people that knows me from other webinars probably have already seen this concept explained, is that most of the decisions, especially from a budgetary standpoint, are based on what they call the tip of the iceberg. And this is basically what I call the CapEx part, the capital expenditure part. That is the first check that every company has to pay. Obviously, this is going to be a huge influence, but in many cases, this tip of the iceberg is just a minor part of the largest figure. So how can we, and what could be a budgetary and strategy reactions if we just focus on this 10%. If you click once more, so imagine now that we might get into, oh, sorry, I got a window on my display. You might have a project manufacturing decision-making process that might lead into, I want to reuse as much as possible all stations. I want to move to an outsourced model because I want to optimize on that 10%. But is this the best solution? If you can click once more. Let's go and see what kind of tool can be used to underline those hidden costs. One more slide, thank you. So let's see what TCO stands for. And again, this is not rocket science. This has been living in real life activities for a long time. TCO stands for total cost of ownership. It's a model through which you can model every investment, and through this you can also analyze what can be the ROI, the return of investment that you're making. I've been using this, someone says that I'm a bit paranoid, also for personal investments, like shall I buy or loan a car? Or shall I make an investment like do I want a solar roof in my house? Is this worth or not? So you can use this model for every and each investment, or every and each decision-making process that implies money, if you want. So what is the point? If you can click once more, Kevin. Again, it takes building. Okay, so you can bucket in three main bubbles: upfront development cost, deployment cost, and operational cost. In upfront development cost, you can consider whatever is happening once in a lifetime for that specific project, like a strategy development, cost associated with tools and training, development effort. Deployment cost is what I called an event-based cost. Every time you have a new deployment, you incur into this specific cost. And then you have operational cost, or the so-called OPEX part. So imagine operator and maintenance, cost of spares, floor space, calibration, inefficiencies, and again.
Can I pose a question?
Yeah, sure, with pleasure.
Can we, for the viewers, can we put a framework around inefficiency? We saw on an earlier slide, we saw a waterfall graph presented by Frank, which was an indication of what the concatenated inefficiencies of the different process steps are, which then when you sum, I guess, is the inefficiency, the physical inefficiency of the whole system. Is it as simple as that, or does inefficiency have many different facets?
No, you are absolutely right. Inefficiency is a pretty large bucket to the point that in some models you have a fourth bubble that is just inefficiency, because inefficiency itself can be defined in many different exceptions. I'll give an example. If you are penalizing the quality of your products, you might not see the effects specifically in production line, but you have an effect down the line with customers, and customers might start losing trust in the product. This is an example of inefficiency across the lifespan of the project, and that's exactly how this operational cost is trying to track this. That is well beyond just the project, the product line or the development of the product, but it spans across the organization. This is exactly why this kind of model also allows to have different stakeholders. Actually, you should have different stakeholders participating to this analysis, because you can have an holistic, unbiased view of how the cost is built up. And again, cost is not just money. It could be cost across the concept of quality, or cost in terms of time, and helps to break what I call organizational silos, because in many cases, some part of the organizations are not talking to each other. Last but not least, it also helps to build, to take less ill-informed decisions moving forward. So that's right.
I'm so sorry. Is it always possible to put a number to those inefficiencies?
You can always translate inefficiencies down the line in dollars or euros or whatever is the currency. Yes, absolutely. But that's just for the sake of accounting. Again, as I said at the beginning, you have to consider that depending on the landscape, you might be more on quality or time, just on cost. So that has to be understood. But For the sake of the simplification, yes, you can always come up with a dollar at the end of the process.
Okay. I have a question that's sort of related to this for Frank. How does, in terms of thinking in terms of inefficiency, how does an exceptionally long process step affect efficiency? When you think in terms of, if there's a lot of inefficiency in that step, then it makes a relatively large contribution to the process as a whole. Is that the right way to think about things?
That's one possibility to think about this. The question is always in front of build and equipment, which kind of information do you have at the starting point? And it's always possible to get information from the development process, from a few to maybe other products, what are related to the new products. We can come with industrial standards. The customer has always ideas about purchasing efficiency, and all information gives a picture what we can discuss in the front of the project.
Okay, thank you, Frank. Augusto, please continue.
Yeah, okay. If we move to the next slide, we can take this as an example of a real life situation where specifically this company was defining a strategy just around this 10% cap. You can see here real numbers. The amortization period in that specific case was around, I can recall whether it was 5 or 7 years. So the upfront cost was around 28,000, but then we helped them through a thorough survey across the different side of the organization. It is a pretty large organization in this specific case, not belonging to the photonics world, to be fully in full disclosure. We identified that the inefficiency or the costs associated with deployment in operational were way higher. If you just consider upfront deployment, actually the operational part was twice as big, the pure upfront deployment part. Now you can imagine how this kind of analysis, once they realize that, how this could have an impact on the strategy moving forward. There is a tendency in some cases to say that existing assets, they come for free. Actually, there is no free lunch in this world. Those assets usually come with a huge maintenance cost and a huge operational cost that is highly underestimated. But since it's not paid up front, it's considered like the lesser of the evils. In reality, if you look at the full picture in this specific case, once you realize that the operational cost, the operational part for this specific case was way higher, they started to redesign completely the strategy. They started to increase automation. They wanted to update hundreds of obsolescence. And again, I'm not saying that this is true for you, but it's important to know that this kind of analysis, starting with the why, starting with the right foot, is going to avoid big mistakes down the line that might affect big time the final checks at the end of the process. So that's exactly the point that I wanted to raise now. That is that we have the why, the how, and the what. So those three points should be combined together, because one leads to the other. And if you don't start with the right step at the beginning, the chances that you're missing something later on, or you're just optimizing something that is local, is pretty high compared to the chance of having a better optimization. The last point that I wanted to raise is that we at ficonTEC, as we show today, we have the capability to provide you across the three areas. Obviously, we have the platform, so the what. Frank showed us that he can work on the how, and this kind of analysis can be performed either for ex post analysis. You want to see exactly what was the impact you had after the process, or as an ex ante analysis to project the ROI and to understand whether there is going to be enough of an ROI making that kind of investment. So there is help and there is support from ficonTEC along those three vectors.
Thank you very much, Augusto. So I guess the takeaways, Augusto has just paraphrased those for us very well. Understanding the why, the how, and the what for high volume manufacturing. The expertise, the capability, and the technology platform is there. And we heard from Frank about the how, what are the important considerations, and where you need to start thinking within the process development workflow about the how, and the earlier the better, although that is not digital. You can enter the process at a later stage with that consideration. And then, of course, the business case is equally important and how that scales over time frame and equally over volumes as well. And I think that's an important aspect of one of the slides that Augusto showed us, is that the operational costs naturally scale directly or even discretely with the timescale and the throughputs that are intended, that needed to be reached for any one particular production line. All in all, take the holistic approach and it will cover all of your bases, and that will help you to arrive at a fruitful outcome for the intended production line.
I just want to make a final, just a very final comment for the audience. If you have specifically on the why, if you want to have a specific discussion around either the existing high volume manufacturing solution you have in place and understand whether there is enough of an ROI, or looking at the dashboard, how it looks like, or you're getting into this activity and you want to get a better understanding along the lines of the process and the business optimization, please feel free to come back to us, and Frank and myself will be super happy to assist you and have an open discussion around that.
Very good. Thank you, Augusto. Thank you very much for that roundup. Frank, from yourself?
Thanks for your time.
Okay.
And feel free. If you have any questions, please send the questions to us and start the discussion.
Okay, thank you. Right, then I will move on to rounding up the webinar. Kevin, next slide, please. So, very quickly, for those who do not yet know, what are the goals of the webinar? We try to keep these short. We're not always successful, but the idea is we keep these short and we keep them guilt-free. This enables an agile format so that we can improve our game over time, or at least that is the hope. And we are, of course, are also open to suggestions, both for content and for approach for the webinar. Please feel free to write to me. Kevin, can you go back one? In these webinars, you will hear about news and developments. You will hear, in particular today, about products and technologies, and in this case, also an approach for high volume manufacturing. And you have an opportunity to pose questions, and we will, if we can, within the context of the webinar, provide an answer, or at the very least, do that at a later date, post-webinar. Kevin, if you want to find out about other webinars, just go to our webpage, of course. If you want to find out more about ficonTEC, you can, of course, contact us. You're welcome to do that at any time. Otherwise, your next port of call would be the homepage. On the homepage, you will find icons which will lead you to our blog, to our LinkedIn and Vimeo presences, to our Twitter page, to our locations around the globe. For example, if you wanted to speak to somebody directly in a language other than, for example, English. We have contacts and subsidiaries and a support network. They're called distributors, thank you, around the world who can help you with that conversation. Next slide, please, Kevin. These are our global presences. We have other contacts that we can add to that as well. You can find out more contact details by going to the locations page on our websites. And I think that pretty much rounds it up. Thank you, Frank, for your contribution. External company Duramentum. Augusto, thank you as well for your contribution. I hope that was useful to everybody who tuned in today. I certainly learned something in the process of putting this webinar together. Anybody else, if you have any comments or praise or criticism, please add it to the chat. Please write to me. And again, gentlemen, Frank, Augusto, thank you much for your time, and bye-bye to everybody who is here.